India has the highest preterm births in the world. More than 900 babies die per day in India due to preterm. Currently, there is no commercially available kit for predicting preterm birth. The kits in development are antibody-based, so there would be a gap between demand and supply. So, it created a demand to develop an accurate and affordable method to predict preterm birth.
In order to discover a biomarker for preterm birth, we started working on the idea that pregnancy is a controlled injury process. So, some injury recovery related proteins must be involved. And we found that the levels of plasma gelsolin, the most abundant injury recovery related protein in the plasma, its levels could be measured and related to the preterm birth.
Dr. Ashish and his team developed the kit based on two things: a biomarker, which is a molecule whose level changes in case of preterm, and a technique to quantify it. For finding a biomarker, scientists in the lab worked on the hypothesis that pregnancy is the most well-controlled injury condition in mammals. So, some injury recovery protein must be involved. This group studies gelsolin, which is the most abundant injury recovery protein, and has found that its levels could be used to predict preterm birth.
Gelsolin is not known to bind to DNA or RNA molecules, so when we started, we were entering an unexplored territory and we were not sure of success. We used Celix methodology to screen aptamer library and found some lead molecules. We used 20 lead molecules and rationally tweaked them and again screened and found 4 molecules which had high specificity as well as affinity for gelsolin binding. These had linear range of operation, so they can be used in an estimation protocol. They are stable at room temperature, which is the main advantage, and as opposed to antibody which get degraded at room temperature. So these kits would be having much longer shelf life than the ones which are antibody based.
Aptamers are first coated on ELISA plates. The serum from expected mothers is then diluted and added to the wells. Aptamers capture gelsolin from the serum. The wells are then washed and incubated with primary and secondary antibodies. Finally, the level of gelsolin is estimated by adding the substrate and recording the absorbance at 450 nm. The time from sample acquisition to final result is about 5 hours.
We are very thankful to Bill and Melinda Gates Foundation for providing us the exploratory grant to develop this plasma gelsolin estimation kit. We are finding from our preclinical trials that mothers who are delivering babies before time have less plasma gelsolin value. The correlation between the data observed is that it is independent of the age, it is independent of the number of gestation, the first child, the second child. What is more important, that it is showing 60% correlation with the time of birth. The significance of this data is so good that it will be wrong only in 4 cases out of 1 lakh. Comparison which you can see with this is with the beta HCG, which is one of the well established biomarker for pregnancy. Beta HCG also has 58% correlation and significance of around 6 in 1 lakh. So we can safely say that plasma gelsolin is a good indicator for estimating the period of gestation. Big advantage gelsolin has that most of the early biomarkers which have been identified by mankind are addressing the early pregnancy. None are addressing the late side or the mid side of the pregnancy. Hopefully with this kit we will be able to find out which mothers will be delivering before time as early as the onset of second gestation period. The same sample which is used for checking gestational diabetes will be utilized for finding this data, and very soon we will be saving some lives at birth.
The kit would serve 15 million babies which are born prematurely around the world. The prediction of preterm birth in advance would help in ensuring proper care at the time of birth. The next version of this kit would cut down the price as well as time required for diagnosis.